Hello, welcome back. The last thing that we looked at was the word problem having to do with the rectangle, so we're going to look at a few more word problems. Consider the following problem. During the 2013 regular NFL season, Peyton Manning of the Denver Broncos threw 16 more touchdown passes than Drew Brees of the New Orleans Saints. Together, these two quarterbacks completed a total of 94 touchdown passes. How many passes did each player complete? So, reading the problem, what are we being asked for? We want to know how many touchdown passes Peyton Manning threw and how many how many passes Drew Brees threw. So, if X equals the number of touchdown passes that Peyton Manning threw, then what would the number of touchdown passes that Drew Brees threw be equal to? Well, what were we told again? So we were told that Peyton Manning threw 16 more touchdown passes than Drew Brees. So basically what Drew Brees threw plus 16. So that means that I might want to change how I defined my variable X. I might want X to be the number of touchdown passes that Drew Brees threw, and X plus 16 be the number of touchdown passes that Peyton Manning threw, because we know that Peyton Manning threw 16 more of those. And I think that that's going to work better for us. We also know that together they completed 94 touchdown passes. So together, which means Peyton Manning's throws plus Drew Brees' throws, is going to be equal to 94 touchdown passes. So our equation that we're going to end up with is going to be whatever Peyton Manning got plus Drew Brees equals 94 total touchdown passes. And now we've got our equation, so we're going to solve for our variable X. And to do that, we're going to combine like terms. So in the parentheses, I can't combine what's there. There's no multiplication here. There's no exponents, no division, no anything like that. So since I can't simplify what's here and I'm not multiplying by anything, I can actually just drop the parentheses. Same thing here. I can't simplify what's in the parentheses. I'm not multiplying by anything, so I just drop the parentheses. And now I'm combining my like terms. So I've got x plus x here, which means I end up with 2x plus 16 equals 94. And to get x by itself, I'm going to have to get the term with the x in it by itself first. So subtract 16 from both sides, and I have 2x equals 78, and then divide by 2. And we end up with x equals 39. So now I should be able to state my answer, right? So we know that Drew Brees, the number of touchdown passes that he threw, was equal to x. So Drew Brees threw 39 touchdown passes. Well, Peyton Manning threw 16 more, so 39 plus 16 is 55. Peyton Manning threw 55 touchdown passes. And to check my answer, if I actually add these together, 39 plus 55 equals a total of 94, and 55 is 16 more than 39. So that works out the way that it's supposed to. Let's look at another example. This problem is actually going to have to do with a percentage, which we did talk about a little bit in the last class. Remember, to find the percentage of something, we would take the percent, switch it to a decimal, and then multiply it by the number. So keeping that in mind, let's go ahead and go through this problem. It says, in the fall of 2015, there were 96 introductory statistics students at a certain community college, which was an increase of 700% over the number of introductory statistics students in the fall of 1992. How many introductory statistics students were there in the fall of 1992? Well, what are we looking for? We're looking for the number of students in the fall of 1992. So having that determined, now I think we can go ahead and set up an equation. So in 2015, we know that there's an increase, which means we have the amount there originally was plus some more. So there was an increase of 700%. So what is 700% as a decimal? So 700%, remember when you convert it to a decimal, you take the decimal and you move it over to the left 2 times. So 700% as a decimal is actually just 7. So I have the original amount of students plus 700% of those number of students. So remember, when you're finding the percentage of something, you need to take that decimal and multiply it by that amount. So what is that actually equal to? So we know that in 2015 there were 96 students. So in order to figure out how many there were originally, I would have to solve this equation. So this is the same as x plus 7x equals 96. Combine like terms, so we'd end up with 1x plus 7x is 8x equals 96. To get x by itself, 8 is being multiplied by x, so to undo the multiplication, divide both sides by 8, and we end up with, plug that into a calculator real quick, and I get 12. So that means in 1992, because remember we have to be able to state this as a sentence, in 1992 there were 12 introductory statistics students. There we have it written as a sentence. And remember that you can always check your work by taking the number of students in 1992, so 12 plus 700% of that. So you'd have 12 plus 7 times 12 equals 96. Continuing on with percentages, we're going to look at investments and how that works. So whenever you are earning money or earning interest on some money, that's percentage. So to find the percentage, again, remember that you take that percentage, change it to a decimal, multiply it by what you're trying to find the percentage of. Now, in the case of investments and when you're earning interest, you're going to want to take your original amount and add what you earned in interest on top of that. Unless you're only talking about the interest and you're not talking about the original or the principal that you invested. So consider the following problem. Gary received $20,000 inheritance from his grandfather. He invested some of the money in an account earning 3% annual interest and the remaining amount in an account earning 2.5% annual interest. If the total annual interest, which means we're only dealing with the interests here, earned is $575, how much is invested at each rate? So what are we actually being asked for? We're asking for the amount of interest that is earned at 3% and the amount of interest that is earned at 2.5%. So this one's kind of got a lot going on, so we're going to organize the data using a table. In my table, I'm going to be looking at the amount that I invest in each account, the interest rate for each account, and the amount of interest earned for each account. So I've basically got, one account, so account 1, and another account, so account 2. I don't know how much I invest in either. So for account 1, I'm just going to say I invest X amount of dollars. But I know that total, the amount of dollars I have is 20,000. So if the rest is invested in account 2, then that's the 20,000 that I originally had minus the amount that I already invested is what I'm going to invest in account 2. Now, in the first account, I know that the interest rate is 3%. So remember, we have to rewrite this as a decimal. So 3 divided by 100 means you just take the decimal and move it to the left 2 times, so 0.03. The interest rate is 0.03. So that means the amount of interest that I'll earn for that first account is going to be 0.03 times X. And then for the second account, we're earning 2.5% annual interest. So you have to change that to a decimal, which is going to be 0.025. You should double check to make sure you understand where that came from. And then that is multiplied by the amount that I invested. So 0.025 times 20,000 minus X. I also know that the total amount that I earn is equal to $575. So it's going to be what I earned in account 1 plus what I earned in account 2 will be equal to the total amount. So that means now we have an equation. 0.03x plus 0.025 times 20,000 minus x equals 575. So from here we need to simplify what we've got there. So right-hand side of the equation, there's nothing to simplify, but on the left-hand side, remember in the parentheses, can I simplify that? No, they're not like terms, so what I'm going to do next is multiplication, and then I'm going to add. So if I distribute the 0.025, 0.025 times 20,000 is 500, 0.025 times x is 0.025x. So now I want to combine like terms. So it's this and this. However, the 0.03x is positive and the 0.025x is actually negative because you've got this negative out in front of it. So this is the same as 0.03x minus 0.025x plus 500 equals 575. So combining like terms, what is 0.03 minus 0.025? Well, that's 0.005. So we have 0.005x plus 500 equals 575. And now to get this term with the x in it by itself, I'm going to subtract 500 from both sides. And I end up with 0.005x equals 75. And to get x by itself, I'm going to divide both sides by 0.005. Which means that I get x equals 15,000. So the first account was how much was just x. So that means that I invest $15,000 in account 1, and then 20,000 minus 15,000, which is just 5,000, in account 2, which you should always be able to write as a sentence. So you should actually be able to state $15,000 is invested in the first account while $5,000 is invested in the second account. One more problem to end this video. This says how much pure antifreeze must be mixed with 3 gallons of 30% antifreeze solution to obtain a 40% antifreeze solution. So here, again, we've got a lot going on, so it's a good idea to actually organize our data in a table. So we've got pure antifreeze, a 30% mixture, and we want to end up with a 40% mixture, and we want to know how much of the pure antifreeze we need in order to make this happen. First of all, we're looking at how much of each substance we have, so the amount of the solution. I don't know how much of the pure antifreeze I have, so I'm going to call that X. But I know that I have 3 gallons of the 30% antifreeze, and the percentage of antifreeze in each of those, well, the pure antifreeze is going to be 100%. So as a decimal, that's just a 1. The second one, I actually wrote this wrong here, has 30% antifreeze, so that's 0.3. So remember, 30 divided by 100 would be 0.3, which means I need to fix it over here as well. The third column that I have is the amount of antifreeze that's in that solution. So x times 1 is just x amount of antifreeze. 3 times 0.3, well, what is that? That's going to be 0.9 gallons of antifreeze for that 30% mixture. And then we know total we want a 40% mixture, and we know the amount of the solutions that we'll have will be x for the pure antifreeze and 3 gallons for the 30%. So we have our equation, because it's going to be the pure antifreeze plus the 30%, which was 0.9 gallons of antifreeze, equals, and I did this again, we don't want 4%, we want 40%, which is 0.4. We want 40% of everything that we've got, which is going to be the x gallons of the pure solution plus the 3 gallons of the 30%. So simplifying here, I can't do anything to the left-hand side, so that stays the same. And then on the right-hand side, I can distribute that 0.4. So I have 0.4x plus 1.2. And here we need to get the x by itself. But in order to do that, we need to get everything with an x in it on the same side and everything without an x in it on the other side. So I'm going to subtract 0.9 from both sides. And I would have x equals 0.4x plus 0.3. And then I need all the x's on the other side, so I'm going to subtract 0.4x from both sides. And I'm going to end up with, divide by 0.6, 0.5, which is half a gallon of the pure antifreeze. So I'm out of time, so I'll stop here, and I'll see you in the next video.